Hello everyone, welcome to this video. In this video, we have to give an example of a group which contain the elements A and B such that they have this property that A inverse B into A that is not equal to B. Now if you look at the question more closely, this is the very simple question. How? Because we are looking for the elements A and B such that we have A inverse B A that is not equal to B, right? This thing is given to us. So what we can do, we can pre-multiply on both sides. If you simplify this thing a little bit, pre-multiplying with A on both sides, right? What do we have? We have A into A inverse B A is not equal to A B, right? This implies we have B A not equal to A B. So here you can clearly see that we are looking for some group which is non-abelian, right? We are looking for some group which contains the elements A and B such that B A is not equal to A B. So do anything comes to your mind at first? So let me take this example. Let me take an example of the group. Let's take this group as S3, right? What is S3? It is the symmetry group. Symmetry group, right? And it has how many elements? 3 factorial. That means in total 6 elements, which are the identity element, the permutation 1 2, the permutation 2 3, the permutation 1 3, right? The permutation 1 2 3 and the permutation 1 3 2, right? So these are elements are there. So from these elements, if we take the element A as this transposition 1 2, and we take this element B as this transposition 2 3, then what would be AB? Let's calculate it down. So when you calculate it, we are looking for the mapping. Let's start with 1. Now here there is no 1, so no 1 is here. What about here? Here 1 goes to 2, right? So here the final answer would be 1 goes to 2. What about 2? 2 here goes to 3 and there is no such 3. So that means this 2 goes to 3. What about this member 3 here? For 3, we will be looking like this. So 3 here goes to 2 and 2 here goes to 1. So ultimately 3 would go to 1. So that means this 3 would go to 1. So that means we have the cycle as closed. What about BA? When you compute BA, you are computing 2 3 with 1 2, right? So we again start with the member 1. So here, while moving from the right to left, you see 1 goes to 2 and 2 goes to 3. So ultimately 1 goes to 3, right? So here you can write 3. What about member 3 while you move from this? There is no 3. Here 3 goes to 2. So that means you have 3 goes to 2. What about the member 2 when you walk in from right to left? So 2 here goes to 1 and there is no such 1. So that means 2 will finally go to 1. So like this, so we have our cycle as closed, right? So here you can see clearly that AB is not equal to BA in this case, and hence we are done. In fact, you can note that any non-abelian group serves the purpose here, right? So you can give other example as well. For example, you can provide the example of dihedral group D3, right? You know, dihedral group that is non-abelian in nature, right? It is the symmetry group of the symmetries of triangle having order 6. You can provide example of group of matrices, right? Which is what? It is the general linear group of order 2 and having entries from real, for example this one. So you can have other examples as well as apart from this example that I have provided to you. So I hope you understood how to go through these questions. Well, that is it for this video. Thank you for watching.